Hi everyone, welcome back to the channel. Today we're going to talk about a photodiode. This is one here. We're going to talk about how it works, some common uses of it, and what actually it is. Starting off, I have a drawing here I want to talk about. First, a photodiode is a p-n junction semiconductor. It has a positive side and a negative side, kind of like an LED. It has a p-type material on one side and an n-type material on the other side. It also has a section in the center known as the depletion region. I'm going to explain to you how that really works. This over here is the symbol of a photodiode. As you notice, you have an anode side and you have a cathode side. And these little arrows represent light, which is used to activate the photodiode. The way this works is it's designed to be reverse bias, which means the battery is somewhat applied backwards. So instead of like an LED, like this was the positive lead or the anode side of the LED, you would connect the positive battery terminal to this. In photodiodes, we reverse bias. That just means turning the power supply backwards and applying maybe like a negative to the positive side of the diode and the positive to the negative side of the diode. And that's called reverse biasing the device. And what that does in this particular device is something really unique. This device has a depletion region, and it has N-type material and P-type material. When you apply voltage in a reverse bias situation, voltage won't continue to flow. Let's say if this was in a series circuit, where let's say it was a light bulb here and you wanted to power it and all that stuff, you wouldn't be able to, because of course it's a diode, so it's going to repulse, it's going to stop the voltage from jumping the gap and completing the circuit. With photodiodes, most of them have a clear surface like I'm showing you here. You notice how clear this device is. It has no color, and it's a purpose for that, because this will allow light to travel through this device. And the reason why we need light to travel through it, because light is what's going to cause this diode to complete the circuit for you. It's going to allow light is going to cause the somewhat like a switch. It closes the switch, allowing current to flow. Without light, current will not flow. It'll flow, but just a little bit, not enough to power anything. So when we reverse bias the situation, you have on one side you have negative ions and you have positive ions, and they try to interact with each other or try to interchange. When voltage is applied, they all run to their own respective sides. Well, when you apply a flashlight or a light source or protons to the surface of the clear coating of the device, that would be used to allow, it actually generates a charge, and in this area called the depletion region, and that'll allow energy to flow, so it'll flow. What I have next, I'm going to show you a circuit that I just threw together to demonstrate this principle. Hang on. Let me just switch out something here. There's a little circuit here. I'm just going to get something lined up for you here. Okay, now, this device I was showing you right here is the photodiode, right? Well, also this device is a photodiode too. It just plugged into the breadboard, as you can see. See how it's clear? This over here is an LED. It's a standard LED that you, like you say, you would power with the positive lead going to the positive or anode side of the device, and you would put the negative terminal to the cathode side of this device. In this circuit, we have a couple things to make this work. I'm going to show you how to make the LED. Not the LED, sorry, the photodiode complete the circuit and light this LED through a battery that's going to be connected. We're going to be using the NPN transistor as the electrical switch, you might say. You got the C, B, E, collector, base, and emitter pins, of course. I have the photodiode positive pin going to the base, and I have the negative side of the photodiode going to the negative, but it's going through this little resistor here, 100 ohm resistor, and it goes onto the positive rail. Remember, we said we were reverse bias, so actually this negative pin of the photodiode is being fed with a positive supply, and the positive is being fed with a negative, as in the drawing here it was showing you. You see how the negative is going to the positive part of the photodiode, and the positive is going to the negative side of that. That's what's happening in the circuit. When I apply power to this this circuit, which I'm going to do now, I'm going to put I'm just going to reverse bias the system right now, and just set that there. Okay, right now I have 3.7 volts energy source power, and so it don't take much just to demonstrate this. I have a flashlight here. It's a standard, ordinary flashlight. And what I'm going to do, remember I mentioned that when light shines onto this device, it's going to create a charge, energy charge. That's going to complete the circuit for you and allow current to flow through the circuit. When there's no light shining on this, there's no energy going to this LED. That's why it's off. Once I apply light, like so, to it, you notice it lights up. This LED here is lighting up. When I remove the light source, it goes back out, because the P-type and N-type material is repulsing itself, so it's not allowing current to flow. It's not closing, like a switch, you might say. So it's not closing the switch. But when you apply light, it creates enough energy to close the switch in the photodiode. And what that does in this particular circuit is, you got an NPN transistor here. So when you apply voltage to the base of the NPN transistor, the transistor acts as a switch also and completes this series circuit, which includes a 100 ohm resistor and a standard LED. So that's why it only lights when, let me see. It only lights up, you can even make it flash even. It only lights up when it has a light source shining on the surface, because it's creating energy in that way. See, light is shining on there. And it's also, every time the light that's shining here closes this, you can say imaginary switch inside, it closes the circuit here using this NPN transistor, and which also flashes the LED with the same pulse rate as it's receiving. So if it's a pulse rate, whether it's a pulse rate or a steady stream of light, the LED will shine as long as this photodiode is getting external light source or protons. Hopefully this demonstration has been helpful in understanding how the photodiode works. Common uses for something like this can be anything like, alarm circuits, displayers, even pulsometers, the things you put on your finger when you go to the doctor. Smoke detectors have them. And also it can measure small amounts of light. Oh well, thank you for watching, and come again. Bye.